Hello and welcome back to module number 4. In this module, I will not go over the assignment, but instead I will try to introduce what is the module number 4 is about, and I will try to cover missing values, function and arguments, loops, logical operating and arithmetics, and Boolean operator. I'll try to do that as fast as I can, but if you are missing something, you will have the PowerPoint to take notes and make sure that you cover. I will not, in this recording session, I will not go over the assignment that I gave you. I will wait until Monday morning, and then I will give comments and give you directions if you did something wrong. And I'm sure that most of you did quite well. So let's start. Missing value. What is the idea of missing values? In a data set, usually we do not have all the values. Sometimes a missing value, sometimes were entered incorrectly. So the R is basically saying when we have a missing value, it's called NA, which means it's a missing value that we need to be aware. And if you have, for example, three numbers, 5, missing value, and 12, in order for the R to give us some directions, we will need to say NA, but again, he will not give an answer. So we can convert it into a missing conditions or a vector missing value, and he will convert it into, instead of true, he will convert the missing value to true or false values. So the issue is that we can overcome that, but we have other way for overcome those issues. So in this case, there's more option to overcome the problem. One of them is na.rn, which is stand for return vector. And in this case, z with refer to the 5 na12, z, and I will say na.rm equal t in order for me to get a value, which is in this case 8.5. So the solution is that we can exclude missing value from our analysis in order for us, if we want to pursue this type of analysis or this type of recovery for missing value. There's other options, example na.fail, na.omit, na.exclude, or na.pass, no action taken. So this is the issue when we have a missing values. But we need to go back to the functions. And as I said before, and I said it again, and I will say it also throughout the semester, functions are the building blocks of R. So you probably created the function, and it probably works as the following. A function with x and y, and it has a return value, and this is what it will do. We can print it, and we can be able to identify, and the issue here that is a print is allowed us to show what is the digits or what is the value in order for us to see what is the calculation behind it. It is as in other C++ code, this is where we highlight or display the result. The issue in R that when you pass a value to a routine, it becomes an argument. And this is really important. So the sqrt is a routine that returns the square root of a value. So sqrt25 will return the value of 5. So basically, what I'm saying here is that in the structure of R, we have embedded functions that are already embedded into the syntax of R. So the functions in R are first class. That means that they treated like any other R object, and the functions can can pass any arguments to another function, as I discussed before. So the function can be nested, so you can define a function inside another function. So function has a name argument and a value. Example, function in R can hold arguments. Example, my data, and I can say a normal distribution of 100, and I can say CD and with my data, and I can say CD of X, and I can say na.rn is false in order for me to, in case is a missing value that is not embedded into the data. So even though it's legal, I do not recommend messing up around the order of the argument so much, since it can lead to some confusion by the R itself. So be very strict about how you construct your arguments using the function. So what is a calling function? You can call a function to specify argument by position, by complete name, or by parallel name. So the argument are matched first by exact name, then the prefix matching, and then finally by position. And I gave you an example how it looked like and how to define them in order for you to perfect match with regard to prefix and the matching, and finally the position. You can also mix the positional matching with a matching by the name. So in this case, I'm using the function formula date subset weight, and I will call the na.action. And in this case, the method will be QR model true, X is false, and the Y is false, in order for me to construct. So this function that I created, just wrote it down. The ARGS function stands for basically the calculation of the mean. In this case, I wrote it in a different way in order for me to verify it. So the order of the operations when giving argument is first, and I want you to have better understanding of it. First, he checked the match, the exact match of the name of the argument. Then he checked the parallel match. Then he checked the positional match. For example, in this case, function A and B, and no, and I'm closing the position. So this is really important in order for us to do that. In addition, to specify the default value, you can also set an argument with a value of the null. So the arguments to the function are evaluated, and so they evaluate only as needed. And so in this case, only in case that you specify that need. So this function never actually used the argument B, so calling F2 will not produce error because the 2 gets position that match to A. And as you can see, I do not pay attention to the B function, I do not define it, but still it's get the same position that match to the A. Next, the 3 dot arguments. And again, I posted the 3 dot arguments. So the function holds 3 arguments, a bunch of individual characters, a string, a more string paste element for the element, and 1 string smashed all together. So the idea here is that in this sense, it will apply and argue with that argument, and by passing it to another argument. So I'm looking at the second example below. Use me, the function arg1. I'm leaving with an empty. I open it again, and I use me, an argument 1 and 0, and again I'm leaving it to close it, and I use it 1, 2, 3, and here it comes, and this is what he will give me in return. I hope it makes sense. I hope this is with the reading will make more sense to you when you are starting to build your own functions. Next, the loop. And loop is a sequence of instructions that usually repeat until certain condition is matched. So a certain process is done, such as getting the item of a data or changing it, and then condition is checked to see if the counter has reached what you have tried to achieve. So the most common loop in R is for while and apply loops. Least common are the repeat loops, and the breaking function is used to break out the loops and the next hubs the process of the current or advance the using of the loop indexing. So what does it really mean? The repeat line or the lines back known as the block of the code. So for the loop, account limited is reached for I in 1 to 10, and the code is, so the loop will run 10 times and it will close the loop, and the variable I update the loop to value that is a sequence between 1 and 10. I hope it makes sense to you. So in statistics, let's take an example and apply that into statistical set of mind. In statistics, the p-value is a function observed from a sample result that's used to testing a statistical hypothesis, for example. So in this case, I will use the loop to show you how to find the p-value. So in this case, the p-value, I'm going to declare, I'm going to open a container, and it's 0, 1, 0, 0.05, and 0.003, and 0.4, and 0.9, and I'm going to use the transform of the p-value into it in order for me to create a loop out of it. So the code that I'm using for the loop is as follows: 4, and the p is in 1, length the p-value, and I'm going to define it by the following the line below. And by doing that, I will be able to create a loop that will give me the p-value. There is another loop, and which is called the while loop. It is repeat a line or lines of the code until the while loop has a conditional logical condition to be reached. So an example, stop when it is true. So the code and the repeat code. So the above loops run the code set, and it stops when it reaches true. But I want to warn you, if the property written in the while loops can be run without end, and so it will keep on running without our ability to stop it. So a simple loop example: we have a container which I call the container v1, and I'm going to do the while loop into it, and to print out what we have found, where I'm going to say print the paste and what I wanted to stop in order for me to understand the loop. I want to go and to explain in the sense of the background on functions. The bytes of codes that done one thing and probably do it well. So the functions break up your code to more mega amenable and more parts, and so by defining them you can do that. Example: function fun is the name of the function I'm writing, and I will say function arguments, and I will call it, and I will say party fun, and I will say in a party usually I like to have food, beer, and folks in order for it to have a good time. So in this case is the function that actually operate. In a simple function, when we are talking about the simple function, we are usually you like to use numeric values in order for us to validate that. And we can use the while loop in order for me to verify the value of what we are looking for. So in this sense, the system.time give me the outline of what we have achieved using this simple function loop into it in order for me to find. Another example, student t-test. I don't know about you, but when I was taught statistics, usually the professor show example of Guinness and control group mean and a treatment to the group mean. So in this case, we are comparing the mean of two groups. So we have a sleep and we have two sets of groups. And by doing the t-test, again, with a loop, we are using the t-test as the function. Extra group is equal, the data is sleep. And in this case, the R will come up with the result that will symbolize or do the loop in order for us to estimate the t-test and what is it entail. So here are some functions that can help you implement the looping to make your life easier. And I list all the loops that I think of in that. One of them is apply. The apply function covers the margin of the array. And all of them are quite nice, and you will see that throughout the semester. Again, how to implement that, try to embed it into your code and see what it will give you. I broke down in every example, and I gave you an example what does it really means. In the Plaply, the first loop, takes three arguments. So a list, a function, and another argument via its arguments. So if x is not on the list, it will be recorded as the list. So I will call the function, I will call it a function x fun, and it will be with three dot argument, and it will give me in the end, fun is an item to match as a function. I hope that makes sense. Another way is to provide numerical values. And again, I can do that with regard to the values, and I assign a values to it, A and B, and I will calculate the value of the $A and the $B in order for me to apply that and in order for me to run the loop. Apply, as I said, is the fun part, the next loop function. Apply is used to evaluate a function over a margin of array. It is most often used to apply a function in the rows and the columns of the matrix, and it can be used with general arrays taking the average of the array of the matrix. So it's not really fast than writing a loop, but it works in one line. So what am I really saying here? If I have a container and I will call it a matrix, and I will say random distribution of 200, and I will say 10 and 20 and 10, and in this case we will apply x and apply matrix, and I will say apply x and 2 as a mean. He will give me the condition that I stated, and it's in one line instead of me repeating again and again, and so the function of the loop is already embedded into the code itself. And again, this is how I do that with regard to the x value when it's 1 with the sum. The shortcut, and there is always shortcuts for sum and the means of the matrix dimension, we have some shortcuts. We can say row sum to when it is equal to apply an x, or row means to apply to the x, or column sum to apply, or column means to apply. So those shortcut functions are faster, but you will not notice unless you are using a large matrix in that context. Again, I outline the next function and you have the PowerPoint to go over that. I will not go over every single one of them because, again, I cannot have 1 hour video and you will fall asleep. You have the PowerPoint to do that. So I gave you an example of sleep, and I want to restart with basic algorithm or arithmetics operating and values. So we have a structure that we already know or really are familiar with when we are trying to take a formula and convert it into the R. So we have division, we have test of equality, but one of the things that I would like you to pay close attention is the X % Y, because we are going to go over that later on when you are going to write your own code, and it will help you to have a shortcut or to apply to it with regard to calculation and with regard to declaration of the values that you have. So this is the basic operating and values that I want you to remember. And next we are going to talk about the logic. So the logic is the study of valid reasoning. So he tries to establish criteria to decide whether some pieces of reasoning is valid or invalid. So what do we mean that we said valid reasoning? So reasoning by itself is a piece of reasoning that consists of sequence of statements such as which are claimed to follow the previous one. For example, either the housemaid or the butler killed Mr. Whatever. So the houseman would have done it if the alarm would go off, and the alarm did not go off, then the butler did it. So this kind of reasoning or logic can be applied to the R. What does it mean? What is mean with regard to valid reasoning? While in every piece of reasoning contain a statement are claimed to follow the form of others. Example, if I will win the lottery, I'll be very happy. Whether I did not win the lottery, therefore I'm not happy. In that context, it's very straightforward with regard to the deduction that I am making out of it. So a piece of reasoning is valid if the statements that are claimed to follow from the previous one, so indeed the follow for those, and in this case I can see the sound of reasoning and how to apply that. One of the things that we usually do in logic studies is to apply the truth. True versus false with regard to what it means. So the argument, the premises, and the conclusion is part of the study of logic, and I will not go over what is really mean and how to apply that. I will try to do that in computer language. Or how do we do that? How do we demonstrate it in programming? So the issue here is that in R and the use of logic for control structure, it is when we going to say the equal, not equal, greater or less or equal to, and this is the syntax that I'm using. So the logical operating in this case is the signs of and, the or and not or, and in this case the 0 is considered to be false and non-zero numbers are taken as true. So in this case, this is the structure. This is where we are going to make our arguments in regard to logic and the conversion of the statement that we are making with that operating system that we have. For example, we have true, false, 0 and 6. So in this case, I can make the idea of testing it, and I will say the idea of how to apply not logic, and it will convert the logic to true to not true, false, in order for me to make a statement. The next one is if everything is false and I want to convert it and I want to add something in between in order for me to test it, he will come back to me and say everything is false. And again, this is how I use the logic into my statement. In order for me to create a statement, it is considered to be the if condition. So the if condition is true, and I'm going to say else, condition number 2, and I'm going to state a statement. If 1 is equal 0, print 1, else print 2. And in this case, the R will go as any other operating code or programming language, and it will cover what it entails. In the case of if-else statement, again, if it will consist of x, 1 to 20, so it will create a sample data, and it will say, I will say, if else, I want you to display, or I want you to calculate for me, x is smaller than 5, and then x is bigger than 8, x and 0. So he will display to me all the numbers that the conditions that I state out or gave the conditions to will be displayed. The root of the logic is based on the calculation of logic. And one of the things that we learned in 1848 is from George Boyle. And he came up with the idea of how do we calculate chocolate and nuts and mint in order for us to create the perfect solution to it, or cheese and pepperoni or sausage in our pizza. And so the idea here is that when we are doing that type of research in the library or in any other platform in the database, we are doing it, we have a structure of truth tables in order for us to state what is it entail. The computing about Boolean logic, it consists of rules, and it is to manipulate input and produce output. We define those rules and to get an answer that is useful to us. So we have true or false and true versus false, and we have the idea what is when we have 3 conditions: true, 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 true or false, and so on and so on. And in the condition of or, when we have that, what we apply to. And we can do implies. In this case, true and true applies to true, or true and false apply to false. I hope that you are familiar with that, and I hope that you are familiar with Boolean operator, as you have learned most likely in C++. And so in this case, another case that we can apply that. So if I can summarize the Boolean logic, I will come up with those conditions. So using the Boolean, I can make a statement, I can create a statement, and I can create something out of it. This is another example of Boolean logic in any programming language. The Boolean in R, in this case, is the idea of how do I phrase it and what do I do with that in order for me to apply that. So in this case, I gave you the syntax in R with regard to how to create that, how to Boolean or for vector, and how to Boolean declaration. And by doing that, you will be able to apply that. Example: the Boolean values are true and false. We can abbreviate to a T and false, so it must be capitalized. So 1 smaller than 2, And if it's true, I can add some more calculation, and it will give me the idea what is true behind it. So according to a textbook, you can invent your own operators. You just need to write functions that name the begins and ends with percentage in order to do that, and I want you to remember that, because this percentage will come up later on when we are going to start to write a more advanced function. So, your assignment for next time. What are the three components of a function? Write a function where you are going to implement your verbal algorithm. Writing the code necessary for each step. A good way to help you through each to do is to make a sample database. You may want to analyze based on past assignment, and as you do each step, you can confirm that the code is doing what you want to do, and you're going to verify it. Another important tip is that you can use another function to check to see if the function is giving the right answer. So save your function on GitHub. The assignment will evaluate whether it's correct or not, and then I will get back to you with regard to the code and how to do that. So, example of an argument. And again, this is a simple example. X is smaller than 10. So you write a function. This is a function argument. I can apply it to different data sets. So in this case, I can do that, and I can apply I can do example search in Boolean. I can make an argument out of it. I can apply to it, and by doing that, I can make the arguments that f1 underscore 1 and empty will give me the function that I'm looking for. I hope it makes sense. If not, please email me, and I'll provide you feedback and directions. Otherwise, I hope you make sense. I hope it was successful, and until next time, have fun.